the given skeleton equation, if not given, frame it. Assign oxidation numbers to the atoms in the equation and find out which atoms are undergoing oxidation and reductions. Balance hydrogen and oxygen atoms by water molecules using hit and trial methods. Add the two half reactions to get the overall reaction and cancel the electrons each side. This gives the net ionic equation. Hello everyone, this is Harshita Bhavasar from Vidhyaashram School of Excellence. Today I am going to start session 4 from the chapter Redox reaction. In the last class, we have discussed about definitions of oxidizing agent and reducing agent in terms of oxidation number and types of redox reactions with their examples. Next, balancing of redox reaction. In that, oxidation number method we have already discussed. In today's session, we will discuss ion electron method. In today's session, we will discuss about half reaction method or ion electron method, which is a type of balancing redox reaction and also application of redox reaction. These two content we will discuss in today's session. Half reaction method or ion electron method. The method for balancing redox reaction by ion electron method was developed by Jette and Lamev in 1927. In this method, the reaction is broken into two half reactions, one for oxidation and another for reduction. It involves the following step. In redox reaction means the redox reaction itself shows that reaction will contains oxidation reaction and reduction reaction. So, to balance the redox reaction by half reaction method, you have to separate oxidation and reduction reactions. To separate and to balance, there are following steps we will discuss one by one. For the given skeleton equation, if not given, frame it. Assign oxidation numbers to the atoms in the equation and find out which atoms are undergoing oxidation and reductions. If they have given the skeleton reaction, it is well and good. If not, if they have given in a statement wise, you have to write skeleton reaction or else you have to frame it, and in that reaction you have to choose or you have to identify which atoms are undergoing oxidation and which atoms are undergoing reduction. Okay. Next, step 2. Split the redox reaction into two half reactions, one for oxidation and another for reduction, and balance the atoms other than hydrogen and oxygen for each half reaction using simple multiples. Same step which we have seen in the oxidation number method also, but the different step is here. You have to separate first oxidation reaction and reduction reaction. After separating, you have to balance other than hydrogen and oxygen atoms by using simple multiples. Okay. Remove the electrons from the oxidation half reaction. Remove the electrons from the oxidation half reaction and add the electrons to the reduction half reaction. See here, already you have separated oxidation half reaction, reduction half reaction. You are equalizing the other than hydrogen and oxygen atoms. How you have to do? In oxidation reaction, you have to remove the electrons. To the reduction reaction, you have to add up the electrons. Next step, multiply oxidation equation by adding electrons of reduction half reaction and reduction equation by removed electrons of oxidation half reaction, so that number of electrons becomes equal in both the half equations. Then what they are telling, multiply oxidation equation by added electrons of reduction. After adding to the reduction reaction, after removing from the oxidation reaction, you have to multiply with each other to equalize both half reactions, okay, till it become equalized. Next, balance hydrogen and oxygen atoms by water molecules using hit and trial methods. To balance here also hydrogen and oxygen, you have to add water molecules by using hit and trial method. Okay, here also two mediums will be there, that is acidic medium or neutral medium and basic medium. In the acidic and neutral solution, first balance oxygen atoms by adding H2O molecules to whatever side deficient in oxygen atoms, and then balance hydrogen atoms by adding H plus ions. Same rule here. If it is oxygen is deficient, add water molecules. If hydrogen is deficient, add H plus ions to the reaction wherever it is deficient. Okay. For basic medium, first balance oxygen atoms by adding H2O molecules to whatever side deficient in oxygen atoms, The hydrogen atoms are then balanced by H2O molecule. If it is here oxygen is deficient, then also add water molecule. If hydrogen is deficient, then also add water molecule to balance the redox reaction in the basic medium. Okay. Take one example to understand correctly. Balance the following redox reaction by half reaction method. Here iron reacting with chromate ion, Fe2 plus 2 getting Fe3 plus and chromate is getting Cr3 plus in acid medium. This is okay. They have given already skeletal equation. Solution for the given skeleton equation, assign oxidation numbers to the atoms in the equation and find out which atoms are undergoing oxidation and reducing. First step, you have to write the skeleton equation. They have already written with the oxidation numbers. Now you have to understand which is undergoing oxidation, which is undergoing reduction. See here, it's Fe2 plus Cr, chromium for chromate, this is plus 6, for this iron plus 3, for chromate plus 3. From here to here, oxidation reaction, from Fe2 plus to 3 plus. If oxidation number is going to increase, that is reduction. If the oxidation number is going to decrease, that is oxidation. Okay. Next, separate the equation into two half reactions. Oxidation half, this is Fe2 plus 2, 3 plus, that is oxidation reaction. Chromate plus 6 to plus 3, that is reduction reaction. Next, third step, balance the atoms other than oxygen and hydrogen. First, other than oxygen and hydrogen you have to balance. Here chromate, here also they are balancing. Cr2 is there, here also 2. Okay. For the reduction half reaction, we multiply the chromium by 2. See here, they have multiplied the chromium into 2. Next, for the reactions occurring in acidic medium, add H2O to balance oxygen and add H plus to balance hydrogen. Thus we get. Now oxygen and hydrogen you are going to balance. Fe2 plus, overall 14 plus hydrogen they have added to balance. Okay. Add electrons in respective side of the half reactions to balance the charges. Thus oxidation and reduction half reactions are returned to the balance the charges as here Fe2 plus 2, Fe3 plus, and here chromate plus 14, H plus 6 electrons are added to form Cr, that is chromium 3 plus and water molecule. To equalize the number of electrons in both the half reaction, multiply the oxidation half reaction by 6. Okay, you have to multiply this width into 6. So 6 Fe2 plus 6 Fe2, this is 6 electron. Add the two half reactions to get the overall reaction and cancel the electrons each side. This gives the net ionic equation. Now 6 Fe plus and 6 Fe3 plus, overall whatever the ions are present, it will be cancelling each other. It will form the net overall reaction. Okay. This is how, by using the overall 6 steps, you have to balance a redox reaction using the method half reaction method. Next, we will take another example. Permanganate ion, that is MnO4, in the basic solution oxidizes iodide ion. Iodide to produce molecular iodine and manganese oxide. Write the balanced ionic equation to represent this redox reaction, or balance the following redox reaction by half reaction method for this reaction. They might ask by statement like this, then you have to write the skeletal equation, or else they might give like this also. The first step is you have to write the skeleton equation, or you have to frame it by yourself. So if they gave the statement like this, you have to write like this, or else if they are given like this, you have to balance directly. For the given skeleton equation, assign oxidation numbers. You know now oxidation number you have to assign. Later you have to divide oxidation part and reduction part. Okay. Here see, reduction is going to replace plus 7 to plus 4, oxidation minus 1 to 0. Next, separate oxidation reaction and reduction. Now other than oxygen and hydrogen you have to balance. For that, in oxidation half reaction, I minus multiplied by 2 to balance I2, and next to balance oxygen and hydrogen by using water molecule, MnO4, MnO2 will form plus 2H2O. Now to balance hydrogen, 4H2O. This is a basic medium, reacting in basic medium. So here also water molecules will be using MnO4 plus 4H2O, MnO2 plus 2H2O, 4OH minus. To cancel H2O molecules common in both the sides, MnO2, 2H2O, Mn gives rise to MnO2 plus 4OH minus. Now electrons with respect to, they have to add here 3 electrons will be giving. To equalize the number of electrons in both the half reactions, we multiply the oxidation half reaction by 3 and reduction half reaction by 2 and write. See here 6I minus and 3I2, 6 electron. This is after multiplying by 3, and now here add 2 half reactions to get overall reaction and cancel with each other. After cancelling the electrons, 2MnO4 minus in the aqueous medium, 6I plus 4H2O and MnO2 plus 3I2 plus 8OH minus. So this is the overall reaction in the net ionic equation. This is how you have to balance the redox reaction by using half reaction method or ion electron method. This is very simple, both the ways also very simple. So don't get confused, practice whatever they have given in your textbook examples itself. It is more than enough. Next, we have seen all what is reduction, what is oxidation now, how to balance, types of redox reaction, everything we have seen. Then what is the applications of redox reaction? Redox reactions as the basis for titrations. In titrations also there are so many kinds of titrations. Usually we will use redox titration. In redox system, titration method can be adopted to determine the strength of the reducing agent and oxidizing agent using redox indicators. Usually in redox titration, we will see the strength of reducing agent and oxidizing agent. The use of indicators during redox titration can be illustrated as follows. They can use self-indicator method, sometimes KMnO4. During the titration of potassium permanganate, as I told, KMnO4, either with oxalic acid or more salt, permanganate ion acts as the self-indicator. Because it's a colored solution, so it will be acting as self-indicator. After the complete oxidation of reductant, MnO ion is oxidized itself to Mn2 plus. During the process, pink color of MnO4 minus is lost at the concentration as low as 10 to the power of minus 6 mole per liter. At this concentration, the reductant and oxidant are equal in terms of their mole stoichiometry. Okay. Another one, internal indicator method. During the titration of potassium dichromate with more salt, diphenylamine indicator is added. Self-indicator, no need of using indicator. In internal indicator method, you have to use some of the indicator as internal indicator. During this reaction, chromate ion is oxidizes diphenylamine indicator just after equivalence point to produce intense blue color. This gives the end point of titration. During the oxidation of iodine with copper ions, iodine gives intense blue color. With starch, this color disappears as soon as the iodine is consumed by the thiosulfate ion. Thus, end point can easily be detected. Usually, why will use indicators? To give the end point, and that end point will shows the complete neutralization has been taken place. Sometimes self-indicator, sometimes internal method. For internal method, diphenylamine will be used when titration is going on, potassium chromate versus more salt. Sometimes to iodine with copper, then starch will be used to give intense blue color to understand the end point and to understand the oxidation reaction. Next, electrode process and redox reactions. When a metal rod is dipped in a solution containing its own ions, equilibrium is established between metal and the metal ions of the solution. Due to this equilibrium, a potential is developed by the metal with respect to the solution. This potential is called single electrode potential or potential of the half cell. Okay. Due to this equilibrium, a potential is developed. Between the metal and metal ions, the potential, nothing but energy, will be developed, and that potential will be called as single electrode potential. Redox reactions involve the transfer of electrons from one substance to another. Usually redox reaction means involvement of electrons. Therefore, redox reactions have the potential to generate electric current. In order to use that current, we need to separate the place where oxidation is occurring from the place where reduction is occurring. What they are telling, in order to use that current, we need to separate the place where oxidation is occurring, where the oxidation is, or where the reduction is going to occur. So, you have to separate. The conversion between chemical energy and electrical energy is carried out in an electrochemical cell. This overall conversion, where it will happen? It will happen in electrochemical cell. Next, spontaneous redox reactions takes place in a voltaic cell. Okay. Non-spontaneous redox reactions can be made to occur in an electrolytic cell by using of electrical energy. Spontaneous energy, voltaic cell. Non-spontaneous energy will be seen in electrolytic cell. Anode, electrode where oxidation occurs. Anions are attracted to it, connected to positive end of battery in an electrolytic cell, loses weight in electrolytic cell. Usually in electrochemical cells, this much anode properties you should know, because whenever you are setting the apparatus, you should know where anode should be connected to the positive end of the battery in electrolytic cell. Next, cathode, electrode where reduction occurs. Cathodes are attracted to it. Cations connected to negative end of battery in an electrolytic cell gains weight in electrolytic cell. The potential developed when a metal is in equilibrium with a solution of its own ions, solution is called electrode potential. Okay. It is represented by E and Rho expressed in volts. Electrode potential depends mainly on nature of the electrode material, nature of ions of solution, temperature and concentration of ions in solution, or pressure of the gaseous substances. This E0 or electrode potential will be depends on nature of electrode, depends on nature of solution, temperature as well as pressure of gaseous substances and concentration of ions. Based on this much of factors only, electrode potential will be resulting out. As the concentration increases, reduction potential also increases. The difference in potential energy between the reactants and products is the potential difference. Okay. Potential energy already you know, that is electrode potential. The difference between the reactants and product is called potential difference. The voltage needed to drive electrons through the external circuit or the amount of force pushing the electrons through the wire is called electromotive force, that is called EMF. Understand? The difference in potential energy between the anode and cathode in a voltaic cell is called cell potential. The difference in potential energy between cathode and anode will we call it as cell potential. The cell potential depends on the relative ease with which the oxidizing agent is reduced at the cathode and the reducing agent is oxidized at the anode. A redox couple is defined as having together the oxidized and reduced forms of a substance taking part in an oxidation and reduction half reaction. This redox couple will be defining where the oxidation and reduction is going to happen in half reactions. Next, standard electrode potential will be represented as E0. The potential developed when a metal is in equilibrium with 1 molar solution of its ions at 298 Kelvin is called standard electrode potential. Electrode potential you know already, but what is standard electrode potential? Standard electrode potential is nothing but same thing, the potential developed when a metal is in equilibrium with 1 molar solution of its own ions at 298 Kelvin. That will be called it as standard electrode potential. If the electrode contains a gas, its pressure should be 1 atmospheric at 298 Kelvin and it is denoted by E0. A redox couple is defined as having together the oxidized and reduced forms of a substance taking part in an oxidation and reduction half reaction. That is the same point. Electrochemical cell. It is a device for interconverting chemical and electrical energies. In the electrochemical cells, it will be interconverting the two different energies. There are two types of electrochemical cells, that is galvanic cell and electrolytic cell. Galvanic cell, a device in which the electricity is produced using the spontaneous chemical reaction involving oxidation and reduction is called galvanic cell or voltaic cell. Example, Daniell cell. About this Daniell cell, you will study in your second PU syllabus. For as of now, if you know this much of electrochemistry or if you know this much of application of redox reaction, it is more than enough. Okay. This completes your redox reaction chapter with all its introduction points, with its types and to balancing the redox reaction and its applications. I hope you have understood completely whatever I have taught in this session and also before sessions of this chapter. So we'll meet in the next new upcoming chapter. Till that, thank you.